Maybe not, but there must be some reason. We have internet all part of the emerging technology, right? Um, Computer cluster, back to the computer science, that involves innovation and trend, looking at the market at that particular point of time will be part of the emerging. If you look at the with the driveless, auto drive or autopilot, no need to hire a driver from the village, right? And then whenever you speak inside the car, you have a phone call, you go and tell people you are talking about billions, right? Millions. There is a delay. Okay, so reduce the so that it will not disturb. Now we understand the layer, right? That we talk in the definition. Did you see the layer there? Yes, go ahead.
Question is, definition, process of creating a three-dimensional object by layering materials based on three-dimensional. Now, question is based on three-dimensional, like that cup, over, you have the inside and bottom. So I'm just trying to figure out.
I will show you how the three-dimensional works later, okay? But it's not too difficult when you have a ball, right? To know that it has a three-dimensional. How you get the three-dimensional? In a primary school, they taught us how to cut the ball, right? Like apple, you cut it, then you have the diameter. You cut it again, you have the radius, right? And that radius show you the three-dimensional. So it doesn't take you that, to know what is the three-dimensional. You have to apply that physics or enter science back in the primary school to know that three-dimensional. It's clear? Okay. So the same thing with this. You slice it, half, and then cut it again into radius. Then you have the three-dimensional. It's clear? Yeah. Like this doesn't show you, right? But for me, I'm seeing it. You see the chopper, you see this, right? Then you see this, right? Yeah. So it's two-dimensional, right? But this is not two-dimensional. Two-dimensional is when you have something like this. Okay? But not considering this. Okay? So it's two-dimensional. But three-dimensional is when you considering this, and this. Right? So whatever it is, slice it into radius, you get the two-dimensional. It's clear, right? Okay. So going back to the definition, it has an alternative name. What is the alternative name? 3D? Eh? So why is it adaptive? Hmm? Addictive. Why is it addictive? Yeah, because you're adding layer on top of layer. So whatever you see here is started with a layer. This is the base. Can I move around? Because I want the student to see from the. Okay, the layer is removed, but this is the base. I can still remove the base. See, it's going layer, and the layer is not going as thick as you see this. It's putting it small layer until it make this wide, and then put on top until it make, and then reduce it until it make this curve. Layer on top of layer, and next side by side layer. Okay, this is the thickness of the layer. Sometimes the layer is smaller than this when necessary. Sometimes, based on the configuration I give to the machine, this is the biggest. Okay, 0.2, 0.025, the thickness, millimeter. Okay, so this is the configuration.
This screen guide, you have a TV, this is the same height.
Sorry?
Screen guide for phone, you have 3D, 3D screen.
The 3D, I don't know how it comes. When you do this, you should be able to do something. Okay? And when you are this, you should be able to do something. And when an object Okay, while she's doing that, yes, no problem. Okay, can you hear me? Okay, can you hear me? Okay, can you hear me? Online, can you hear? If you can hear me, say yes, please. Okay, let's continue. After creating the model, you need to slice the model, right? The idea is to make sure you give a sequence in uninterrupted manner so that we can have a successful printing of an object without any issue. What happened during that slicing? It tells you if your model has an issue, and it will identify those areas that has issue. Okay? Most of the time, we create a model, right? We think it's okay. Just yesterday, somebody come with a model to print a casing for the power bank. But actually what he did, he printed a power bank. He printed a power bank, not the casing. I'm lying. Show them that model. Put it on that computer, on it, you will see it. He print a power bank. Okay? So this is a problem, right? When I print it, I print a power bank with the socket, outlet, and everything. So I tell him, no, I can't print this for you. You have to go back and do it. If you want, you can come and join our class, maybe learn how to do it. And then someone is helping him. And he think it's all right, right? They print a power bank for him, casing. He want to create a power bank. This guy has innovation. He don't know how to create a 3D. This is advantage to be in this class, right? But it's too little, too late. So he asked somebody to do it for him, and that guy print a power bank for him, a dummy power bank, a toy one, right? And it looked good. Even the dungeon are there, and you mark it with green. The power, you mark it with red. I told him, come on. The power is something you buy and put. You just need that place to be fabricated, so that, and you need a place where you will cover it. You know, after you put all your component, then you cover it. Bam, it goes in like a phone. So now he realized, yeah, they messed up. So he went back and tried to resolve this issue. During the slicing, okay, we identify many things. The 3D model has the horizontal border, you call it, the layer, the first layer. This guy, he go beyond the layer. His model of the power bank is at the middle of this layer. Okay, so like I want to print, this is my board, so it starts from the bottom of the board, then to the top. Usually it should start from here, right? This is how it should start. This is the base, it should start from the base up, right? No, this guy in the middle, the base in the middle. There's a problem, right? So I show him how to bring it up and how to, do things, but the remaining thing he has to go back to his consultant to do it for him. And so you have advantage if you are doing any manufacturing. If you learn how to do it, it will be easier. Even if you have to hire someone to do it for you, you know that there is something need to be done, right? And you can coach him. Hey, this is what I want. Because maybe that guy just know how to do the AutoCAD and all that, but he doesn't know how to print it or how it takes, the other processes like slicing and all that. Okay? Then that software helps you to resolve many issues related to your model. After that, yes? That software, okay? That software helps you to resolve that particular issue. After that, we now start printing. The printing activity involves many things, right? It involves, injecting the filament, the temperature of the head, right? The temperature of the head, and it involves the calibration of the nozzle, right? It involves also precision, the testing of the motor that moves the item from one place to another. In some 3D printer, it moves the item, and the nozzle is at the middle. Like ours, the nozzle moves. It tested before it starts printing to make sure that that thing is possible. It look at the environment of your printer to see if this model can be printed in that environment or not. If you bring the model which is larger than the object, it cannot be possible, right? When I put it in our environment, that model, we put it this way. It goes right at the edge of our environment, the tray. But I help him to twist it. So we do it the other way around, not east and west, but we do it by south, north. Fixing the problem, right? But I can't fix all the problem. I want him to go back and, he pay the consultant, right? The consultant has to make it. Yes. So all this can be identified. During the printing, as I mentioned, the temperature, okay, the nozzle calibration, the environment calibration, and many other things, motor testing and the movement and all that, then it starts printing layer by layer. Layer by layer. It starts with the base. Why it need to create the base? Because you don't want your print to have an issue when you are done with the printing. You cannot remove it from the tray. You want it to be easily removable, right? And you don't want it to move during the printing. If it moves during the printing, forget it. I will show you some example of what happened during the printing because of some errors. It could be a human error. It could be a machine error, or it could be a situation error. Abla, Banu model in the aka kan cut. Give me that model that the cut head is not completed. So we had a situation where our electricity went down. They were doing some maintenance outside. They didn't inform us, and then we printed it. We printed until this size. Yeah, we couldn't finish the remaining one because there was a power failure. When the light goes back, we try to continue, but this thing already moving. We try to hold it and do anything. It's not doing what we are expecting, so we have to give up because some of the layer already missing. So there is no way it will continue from here. You get the point? So that is the problem. So you have to also consider that. Make sure that your power is uninterrupted during the printing. Because this is the base. I still can remove the base. It sticks to the tray. But once the tray is cold, after some time, this is movable easily. That's the reason for creating the base. It holds it when it's hot, new. Once it's done, completed, it will ask you to remove your model. By that time, the tray is, when you touch it, it's movable. But before that, you'll be struggling to remove it. And you may even spoil it because at that time it's a little bit hot. Right? So this is it. Our printer is one of the best. I could continue this, but I want to use it as a case study to show the impact of having electricity. But we printed another one, which is completed. It's very nice, very cute. Okay? So expect anything while you are doing the 3D printing. If there is any, there was a situation I'm printing something, then the electricity goes off, same maintenance. Then when it come back, I quickly come, hold it, it continue, fine. Then somebody say, this thing, can I touch? After touch, it shifted. And I cannot bring it back to that location because I don't know the location. I would try, I will fail, I know. Okay? The location is not, even though it gives demarcation, but I cannot be so precise. And if you have any shift, you will see it. Okay? You cannot be as precise as the machine itself. And the machine will not be that, in compared to, once you mess up, the machine continue what it's doing because it's been programmed, right? Yeah, so that's the thing. After that, we do the post processing. Once you have the printing, sometimes we print, you have to come and remove the base and all that, right? See, it's easy to remove. Very easy. This is the base. Now I have normal. Sometimes no, like this. I have some rough area. I will do some cut with razor or knife or something like that, or do some paper or grind. It depends. Like this place is not smooth. I can now use some additional tools to clean it and do some cutting or polishing if it involves polishing. Just imagine you have to print a teeth for dentists. Yeah, they do polishing. When they print, they have to do some polishing to make sure that it's looking nice and smooth and all that. If you look here, it's layer by layer. Still, it's showing the rough, right? Though it's smooth, but it's rough. You can feel it. So if you want it to be smooth, you have to come and do the polishing, sometimes waxing and all that, right? Depending on the type of the material. Is that clear? You have any question? Yes.
There's polymer. Polymer is the material.
No, we have different type of material, but this particular one is ABS. Yeah, it's ABS. It's a mixture of plastic and fiber. I will show you this.
Okay, so other materials can be used.
There are many materials. We have material which are plastic type. We have material which are epoxy type. We have material which are metal type. We have material which are titanium, aluminium, depending on the type of the printer. Some printer cannot print with the metal. Even we have a 3D printer that can construct a room. You put the cement and that is the filament for it. It creates, structure and houses, building and all that. Okay? Is that clear? Yes, go ahead.
The question is, aside manufacturing industry, what areas can 3D?
We'll come to that. We will come to that. Okay? We will come to that. Okay, good. There are different type of technology that we can use for 3D printing. Okay, these are few of them. Okay, we have FDM. Okay, it's usually or mostly used for prototyping when you are creating a prototype of an object. Okay, and we have SLA, which is used for leather. Okay, rising idea for high precision parts and so on. So when you are dealing with this dental equipment or something like that, you need to consider using this to be more precise. We have SLS, okay, which is used the leather also, sinter to power the material. It's plastic, sometimes metal, okay. It is more durable, and when you are dealing with some complex parts, something that you want to send an item to a space, you need to make sure you use some material that cannot be decayed by the atmosphere there in that environment. So you need to consider maybe mixing a metal with the plastic, and or considering the use of even waste, right? You sending something to the Jupiter, you have to make sure that it's not a material that can be, melted or, in that environment, and it can resist. So this is the idea. Then we have DLP, okay, which is similar to SLA, okay, but it is lighter. When you are trying to create an object, but you want it to remain lighter with the same strength. Okay, you heard about fiber, right? Most of the time, fiber, you will use a toothbrush, they say it's fiber, blah, 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 right? Why fiber? We have the fiber optic for the network cable and all that, network equipment. Why? It is fast, durable, and it is lightweight. Okay, so this can be one of the advantage. Then we have SLM/DMLS, okay, which is a metal printing for creating a strong metal parts. This usually used in aerodynamic, aerospace and automobile. Okay, sometime a Department of Defense will create some object that they try to make sure that their drones cannot be easily exploded by the rocket and all that. So they put a different material, right? It can go even inside where the bomb is exploding, or the bomb exploded while it is there, and it still resists, go out and capture the event, and then bring back the the footage to them. So these are the kind of application or type of printing that can be done. Let's go through the application. Oh, let's look at the material first. So we see different type, right? And different type depending on the type of materials that can be used. Okay, what are the materials? We have a plastic. This is ABS. Okay, how many type of plastic we have? We have three. We have PLA and PETG. They are best idea for prototyping, right? We have a metal which can print a stainless steel. Usually our spoon is stainless steel, right? It can print a stainless steel. It can print a titanium. You know what is titanium? No, right? But we heard about it, right? A lot. Yeah, it's a type of metal, very precious, and look like a silver, okay? But with the different description and strength, okay? We have aluminium, right? Aluminium is most of the motorbike engine is made of aluminium, right? And what?
Some car engines also is made of aluminium. Some the body of the car also is made of aluminium. Yeah, so you can use that to print also. The aeroplane, I believe, is something like aluminium, but not aluminium. Maybe that's a titanium. Alloyed? Alloyed is aluminium. You know the problem why I say it's not aluminium? If you try to welder it like the aluminium welder, it doesn't work. I have a car that has the same metal. If I have an accident, anything, I have to change that part. Eh? Try it crack. The more you try to bring it back or something, it crack. And I know that the aeroplane, you don't have a welding, you have rivets.
Fiber.
It's not fiber. It's aluminium, but I think it's that titanium. I'm not sure. I don't want to say something that I don't know. But that car has the same material. That car has the same material. I noticed that when we got accident and trying to fix it. So you have to change that part whether you like it or not. Okay, so if it is metal, it's easy, right? You can use even the solder and make a place heat a little bit more. But this time around, it's either I go for 3D printing and print that part, or I have to change the part completely. And they are advising to get the metal type from China. I say no. Try to get maybe from another car, which is things like that. We're still looking for it. Okay, so metal, stainless steel, aluminium, and titanium can be also printed with a 3D printer. Okay, mostly in aerospace. So I believe the titanium is for the aeroplane. You know why? Usually aluminium is lighter, but the titanium is lighter than the aluminium and it's more stronger. Okay, it's more stronger. One of my professor told me that they cook the plane. When the plane come back, they cooked it. Yeah, they cooked it. I don't know what they mean by cooking. So I asked him, how did they cook it? He explained to me it goes into the garage and they do something to rise the temperature, do blah, blah, blah. He's explaining in the technical term that I don't understand. This is where all the rivet has to go back to its shape, because after it goes up and land, take off and land, and then hit all these, that stone, this atmosphere that makes it, on the sky, the rivet get weak, right? Now it come back, they cannot start using hammer and rivet, checking all the rivet. They cooked it, and then it will strong again. It's ready for another flight. He explained in technical terms. That was in 2008 or 2007 he was explaining. I couldn't remember. I can't understand what he's saying because I'm not in that, that field. But it means something, right? Something is happening. Yeah. Then we have the rising. Okay. Rising. So it can be used for engineering. It's usually used for cascading. You know rising, right? Epoxy. Epoxy, when you mix some, you use 4 minutes. 4 minutes is rising. You put the A and B, you mix it together, it becomes a plastic, right? So we use it for gunning. Actually, 4 minutes is epoxy. Indirectly or directly is epoxy. Okay, so rising is you mix A and B component. This one is hardener, this one is rising. You mix it together, it gives you either a glass or a plastic or whatever. It could be a silicone and so on. Okay, so that's rising. We have composite, which combine the carbon with a plastic. I have seen one technical guy did something amazing. When I send my car for repair, to repair my air condition, then the mechanic did something intentionally. I say intentionally because I caught him intentionally. He did it. He punched my radiator. Then water started to come out. Actually, the coolant started to come out. What happened? He said, "Oh God, this thing." I said, "Okay, we need to buy a new one." He said, "Yes." I said, "Okay, do you know anyone who has it?" Yeah. How much is it? He said, 25,000. I said, "Okay, bring it." He said, "The good one?" He said, "Yes, bring it." They go and bring it. I said, "Okay, you pay for it." He said, "No." I said, "No, you are the one who punched it. Am I? Did I ask you to do anything in that part?" He said, "No, you have to pay." Then now, okay, we could do something. We can go and solder this thing and make it. Actually, that thing is coming from his friend. He wants his friend to also get money. He got already enough money for repairing the AC, and he wants his friend also to get money from academician. Is that good? See, poor academician. Then they say they will do something, and I say, okay, you put this lead and all that. They say no, there is something we could do. Another technical guy come to say, what can you do? He say, I'm going to use 4 minutes, but with the metal dust. This grinding machine, right? The milling machine, they do the grinding and they sharp it. They take the dust and they mix it with the 4 minutes. Believe me, it's strong like a metal. So that's the carbon, right? And he put it until now, it's fine. After he put it, he said, "Oh, got 15,000. I said, "Good, pay him." You know how much they pay him? They pay him already just, I think, 700 or. But for me, I have to pay premium, right? So when I see this combination of plastic and carbon, it reminds me that guy, very funny people, in Adamawa, they did this. So it's a combination of plastic and carbon to make that particular thing stronger. So next time you want to do something with the object, 4 minutes, don't just leave 4 minutes, right? Put some carbon. It will be stronger. I learned from these guys. And we are learning now from 3D printing. Because some of the 3D printers, it take the filament of this ABS and it added this carbon on it. Though it will change the color, but it will be stronger than this. It will be difficult for you to even destroy it. This one, if I use hammer, it's easy, right? But that one is like I'm destroying metal. Okay? So we have food material. Some they want to open a bakery, right? Some people come here to print a cake, the cake dummy, so that they will put in their drawer, right? To show that this is the kind of cake they are selling and all that. But no, you can use the 3D printer to print the cake or to print this item that you put on top of the cake. Happy birthday. The customer come, today is my birthday, or today is my friend's birthday, and this is his name, he's 30 years old or he's 60 years old. Can you please make it very attractive? Yes, I can. Mr. John, can you print this for me quickly, right? You go and print with the plastic and his name, bring it. They can't just have, all the names of everyone there, right? If you know how to do this, you have the model, you just put the name and you print the model and you can put it on the cake. Though, you can also print the cake. If you can print a human body using a bio ink, then you can print a cake with a flour mixture of all the, this, what do you call it? The cream and all that, right? It will be more precise than the human, right? Believe me. Yes, now, if you allow that kidney to be transplanted into your body, then I think you can allow yourself. Hey, by the way, how many times you eat something which are made by a machine? How many times? You eat a hot dog, right? How is it processed? It's a 3D print, right? Printing it one after the other and sealing it in the plastic, right? It's eatable, right? Biscuits is coming all from the machines and everything. Okay, so you can print the cake, you can print a donut, you can print anything, right? Donut, but you have to fry it, right? Or bake it. Anyway, I have seen a place where they create this like Arab bread, the round bread, very fine looking. And I'm wondering how come this bread is becoming very round and very nice and soft and a little bit dough, you can feel it. One day I went there while they are processing. I usually go there around 3 to buy. This time I say I will go by maybe 1 o'clock. I went there, I saw. They put the mixture of the flour, everything, and they put inside the engine mold, and it's coming in a belt, and then there is a cup that come and shape it. When it goes, it goes. This one goes the other way, and they return it again, and I say, okay, no wonder it's so fine, it's so cycle. It's done, the molding and everything is done by machine. No human involvement until it reach to a place where they have to put it inside the oven. Putting it on a tray is done by the machine. All the tray will be carried by the guy and push it inside the oven, lock the oven. After some minutes, he knows time is calculated, he bring it out, it's ready made. So it revolutionized the process. Okay, so we can have the design and we can use all the. Let's look at the application. This is the most important. We have the 3D printing, we have the 3D printer, we have the 3D model. If there is no application, what's the point? It's a waste of time, right? So let's look at the application. We can use it in healthcare. Healthcare a lot. They use a lot of 3D printing. One thing I'm not sure, the cataract, when you have issue with your eye, there is artificial lens, right? Is it made by 3D printer or is it made by, I'm not sure, right? But for sure, what I'm sure is that a part of bones in a human body can be made by 3D printer. Yes. Some time ago, there is a friend of mine that his in-law has an issue. They have to replace one bone from the waist, her waist. And they ask them if they want artificial one or they want the real one. The one, yeah. So they cut it from somebody's body. And yeah, dead person. Usually in UK, if you want to get a cheap insurance, you sign the contract that you let your body can be used for research or transplant, and then you get easy, for the the treatment. So after that, but sometimes if you sign that, people have some concern also, because a friend of mine also signed that, and he has a concern that people are saying that you come with the small illness, they make you die, and because they need something from your body. There are a lot of complaint about this. I'm not making it up. It's there. I've seen it on the internet long ago. So if you go there, you sign that. They look at your demography. Okay, I don't want this to go. But anyway, there are something, right? Why we are talking about it, whether a real one or artificial one. You can have artificial one, it will be as good as the real one. Just know that you are using plastic instead of, even when you have a fracture, sometimes some bone has to be removed and put a metal, right? Yeah. So they can put something, an implant or anything.
For a while.
Yeah, it's been done, but for the joint, sometimes they cannot have the same size, so they have to print it with a 3D printer and make it, use it. The teeth, you can use a 3D printer and print it and join it, fix it. Even the gum, sometimes they can cut it if it's spoiled and create a 3D model of it and with a different type of material and then fix it, adjust it. Have you seen an old woman video where she removed?
Yes, absolutely.
Was nothing there, right? And when she looked nice. Huh? When she removed, she smiled. You don't want to see the second time. Yeah, so with all the 3D printing, all this done by 3D printer. it make the process even faster. Okay, we. Okay, this is another thing. It could not. Even taking the real one could have a side effect. We have something called organs rejection. That's why the 3D printing become more successful, because if they want to print, for example, the kidney or heart or liver, they take the gene or the cells from your body. So there will be no organs rejection. They harvest it and incubate it until it reaches a level they need, and they use that ink to print whatever and then put back in your body. So you will not have any organs rejection.
The medical science is printing
Yes.
heart or kidney.
Yes. You search it. They are working on it. I don't know if it is successful until now, but I know about the kidney. I told them, right? In 2007, I have seen that research, and they successfully to print a kidney with bio ink that lasts for 6 to 7 months. So from 2007 to today, you search, you help me. Next class, you will give me the result. I believe this is the thing. You know how many million people waiting for kidney transplant in China every year? More than 500 million.
I heard there are some locations
in India. These homeless people, homeless children, they cut them and take the body, throw them, and sell it to somewhere or bring it to UK. No, you are lucky here. They give you. In India, they will just homeless. Yeah, they will put you in this black SUV, and they will go inside the SUV. They cut. They take what they want. They seal it and throw you. Who cares? Do you care about yourself? You don't. They don't care about you. They need what you have.
Weekends.
They need to live, right? So you are lucky in Nigeria, they give you 1 million, right? You can buy iPhone, I've seen somebody in Netherlands, he sell his kidney and buy iPhone.
In Africa, we have culture. We have culture.
Yes, now. He want to have iPhone, right? The easiest way to sell his kidney, right? Yeah, it's a business. And you are lucky. Some of the country, they create a war just to be transporting the organs. Diplomatic Republic of Congo. Okay, we are not here for that. Let's talk about this. Yeah?
It's part of life.
No. I may be charged for saying this thing, but I know if you charge me, I have the evidence. But let's not degrade. Let's go back to this. In China, about more than, let's say 500. I reduced it to 5 million. Because if I remember well, what I read is 500 million, but let's say 5 million people waiting for kidney transplant. When is going to be your turn? How many people you need to kill before you get the kidney? How many people need to die that willing to leave their kidney for transplant? How many of them has a good kidney? Those who die. Maybe they die because they don't have a good kidney. So put yourself among those who are dying, right? In the next few.
How did they get the material to print the bioprinting tissue?
That's why, yes. When you got, like, I don't know, when you have an accident and you have a fracture or part of your skin is removed, you cut from one place, right? And put it somewhere, right? So they can cut somewhere and harvest it and, incubate it and get the bio ink from that. This is to avoid organs rejection. It's one of the advantage. Okay? We can use it in aerospace and automobile to create a lightweight object. The aeroplane, right? It needs to be light, right?
Very strong.
It needs to be strong also. Because those things is better than, between Kaduna and Kano, Kaduna and Abuja, before Lere, there was a heavy pothole there, right? Not good. Not good. The road is not good, right? Sometimes you feel higher than that above the sky.
That's
the
actually
impact.
as a result of water vapor content. In the
Yeah,
atmosphere.
so the atmosphere is heavy, thick, and all that. And sometimes if you're not lucky, you go in, there is a lightning inside. Oh,
Turbulence,
you'll be wondering who sent me. Why did I even started this journey? Eh?
Technology have advanced.
Whatever the technology, I have used all the airplane, A380, whatever, blah, blah, blah. I feel the impact. And for that, I don't want to even travel now. I have phobia.
Current weather radar.
Forget about it. Forget about it. When you are there, you will know the reading.
From what you say, there are certain regions that it's perpetually there. There are certain countries that
See, if you're talking about Southeast Asia, they know their weather. They know how it is. Believe me, one day, I'm just traveling between Al-Aqsa to Jeddah. It's usually nice. It's usually no. See what I feel? Just for 2 hours journey, we wasted more than 20 minutes, 30 minutes trying to, renavigate or something. We come down, nothing. We go up. I say, okay, it's happening. Just between Egypt to Jeddah, one day it was a horror. Not Jeddah to Dammam. It's horrible. That day we lose 1,000 altitude.
As a downdraft.
Somebody very heavy is not wearing the seatbelt because everyone was relaxed eating. His head touched the cabin. About 1,000, because I was looking at the screen, right? I see our altitude. And I see when this thing happened, I look again. I'm seeing we lose the altitude.
Turbulence as a result of.
Yeah, so I think he have seen something and he just bring it down. Or he's sleeping, he hit that thing and we go down. I don't know. So my stomach is like it goes here and then go back. Right? So it needs to be lightweight because if it is heavy, it will spend more fuel, it cannot have more efficiency, it cannot carry more luggage and all that. And the idea is to be more efficient, right? And it needs to be strong.
Streamline.
Yeah, so you have to balance. You have to balance. Fashion and jewelries. We want to have a jewelries which look nice, right? Perfect. If you go to India, you see how they're making the jewelries. It's amazing. I've seen recently how they make the flowers and all that. I cannot imagine the creativity and how they do the waxing and all that. At the end, how they do the finishing and oh, it's amazing. With the 3D printer, it solved the problem. That's why Chinese are beating them. You see, you have this Turkish scarf, made in China. That one is handmade, right? And expensive. Now China make the same type. And call it Turkish. China make BMW, make Mercedes-Benz. Because they have this manufacturing revolution that they can make everything. Adidas, everything. Even Mercedes-Benz electronic. You've seen that? Even in Germany, I didn't know if there is Benz electronic yet, right? But there is in China. Most of their Mercedes, I think it's Chinese Mercedes, right? Is electronic. And the charger, they don't even use that conventional charger that you have to go and pay money. No. Just get the outlet from your house and they have this combustion. You just put the outlet and put in your car. Finish. Easy. Because they want to revolutionize, the process and make things happen. They want to be the chair. And so that's why the 3D. Okay, the passion. We want to print something nice. Something cute, right? We want to print something right away. There's some event, you want to print the ring with the name of the husband, the groom, right? And the bride. So you need to wait to get the order from China or You need to plan ahead of time. Maybe there will be some rearrangement. You don't want that lady anymore, or she don't want that husband anymore, that boy. Okay, so you want to do it like day before, right? To be safe. You don't want to spend millions and then you have to. Have you ever printed a wedding card and then you have to cancel the wedding? It happened many times. It happened to some of us here. I printed the wedding card from abroad, a special type of wedding card. I have to bang it, not tearing because I lose, tearing my money. Just kidding. Okay, let's continue. So you have some customized item, right? And the 3D printing can help. Then the construction, we can have these 3D printing in construction, where if you go to these developed countries these days, they do casting in terms of building skyscraper and all that. That casting can be done with the 3D printing and just plug and play, and tight. You already see a building. Sometimes, no, the 3D printer will be in the middle doing. You have seen that video before? I'll share with you in the platform. Okay? It's printing the room, the house, and putting everything with the mode that goes inside the 3D printer, but a special type of mode that dries not immediately, quicker. Because if immediately we have a problem, right? Immediately you have a problem. Sometimes even it can dry inside the machine, so that's a problem. And it becomes a concrete inside the machine. Now removing it from the nozzle is going to be another issue. Yeah, so that can help also when you want to build a temporary shelter and so on. But not only the temporary shelter. I've seen where they make a casting the whole, like Julius Berger. They want to make a building. The whole room will be built, and then they will take it with a crane and fix it. Right? This makes life easy.
Almost designing solutions, design, copy plan, transfer.
See? So that's one of the application of 3D printing. We have consumer goods, which is customized product like phone casing and all that. Yeah, you can use it. I have one of my students in another institution. He went for internship to one of the organization. They have a 3D printer, and he print a wallet, a 3D wallet, which can slide and open, and he can put his cards in there, and he print a case of his phone. Very nice. So we ask him, where is ours? He just print for himself, right? But which is good. At least he knows the application. He knows how to do the slide. He knows how to arrange things. Like for the casing, it's just one piece, but for the wallet, the special type of wallet that you slice it so it opens and you put your card in there and it's interactive, like 4 different items put together. Okay, we'll show you a few of the models that we have there and how we can pick them and put them together. So you can print all these customized items like glasses and all that.
So when you say shoes,
yeah, you can print a 3D shoe.
the one that one will
See, assuming you have somebody with oversize. You don't want to make a handmade. Like Nike, you have some design. You can make it. So you bring the source to this material, then the top you print it with a different material that look like Nike. Or you want to make a different type of shoe, like those shoes that track people activity, coloring, and the weight and exercise and all these things. You have all the technology to do that, but you don't know who can help you to create this shoe. So you can use a 3D printer to put everything integrated within the machine. Have you seen the shoe like yours that track your activity?
Like the smartwatch.
Yeah, the smart shoe. Now Adidas, Nike, Reebok, they all have. It's connected to your phone and also your personal vector application somewhere on the cloud. And you can keep track of. You don't need to put the application on the phone or on the, your blood pressure is there on the shoe. Whether you have enough calorie or not, but I think I like the watch because the watch every time is in your hand. You can, even while you are sleeping, but you can't sleep with the shoe, right? No, if you sleep with the shoe, I think there is a problem. I would think you are an American, right? You go bed with the shoe. Even in UK, I don't think they do that, right? But I've seen some musicians, they go bed with the shoe. Yeah. In America. Okay. What are the advantages? What is time? Do we have time? Yeah. What are the advantages? Customization. We'll be able to customize the item. Okay? I have a bag which is LV. I can customize it with RI. LV. So it's another version of LV, right? I'll put my initial names also on it. It'll look like mine. Okay, you can customize. Okay, create a product which will be based on the individual needs. Okay. For example, just now I mentioned about some people have, mashallah, a good big leg, right? You need to go for handmade item or even the size of their clothes. So you can use that 3D printer, give the size and print the sock or print the shoe itself. One thing you need to learn about 3D printer, you can print a model with a different type of filaments. Maybe I want to print this, the cut at the top, I want to put a hair. When I come to the hair part, I will use a different material. So it allows that. Once you put it in the model, once this particular thing finished, the next is coming, it will tell you this is time for this, change the filament. So you need to change the filament and put a right filament for that. Clear? So you can create a customized product and complex design. Sometimes you go into more complex, design. Let's say this like Jelani when he created a transparent car. The engine to be transparent. So the bonnet and the head of the car, the paranormal, right? He's the first one to create all these things. How can he do that? Easily print the model and show it. You need a 3D printer to fast track. Okay? And GMC adopted that. They have many type of cars now, right? With the transparent. Even other companies are now, even adopting this thing. So sometimes it's complex. It involves some shapes, some mechanical engineering, and a lot of technical skills required to make that prototype happen. Then we have a speed. You want to make something faster, like a wedding tomorrow or a birthday. You just know your Oga birthday is going to be tomorrow, Sunday. I want to impress my Oga. Quickly go and find somebody to print some, 3D model of your Oga and wish him birthday when he comes to the office, because you have a permanent seat in your office, yeah? And you want to be promoted. You don't want your promotion to cry. Yeah, so it's faster and it becomes, if you are running low volume items, so it's easy. But when you're dealing with a large quantity, you need to rethink. We have some people that they want to use our 3D printer to print about maybe more than 300 objects of this Abuja Tower, what do you call it? So we tell them, how long time you want to sleep here or what? We have just 2 3D printer. They say they will bring theirs. Okay, fine. But I don't think they can finish that items if the model is right. And I asked them the size of the model. It's almost impossible to finish it within a month. So because the quantity is large, right? So it will take time. But if just one product, 10 quantity, not much, you can do it fast. But when it reaches to 300, it's better you hire somebody to go to China, do it and bring it back, right? They can do it within a week and bring it back. While you are here 1 month, you couldn't finish. And imagine that the electricity is up and down, even though we have standard power here.
It's not a disadvantage.
Yeah, you can think about disadvantage when you are printing a large quantity. You need to have more 3D printers, right? And it's extra cost. But the advantage, if you are going with lower, it's faster.
So how about cost of printing, trading?
It's between, it depends on the type of material. But per gram of filament, between $2, let me check. It's here.
But they are China.
No, in America. No, international. In China, it will be cheaper, you know. Even the filament, this ABS, they will use something and call it ABS. Especially when they know you are from Nigeria. For me, I never order things from China direct to Nigeria. I order it from China to China, put it in warehouse, then pack it from the warehouse to Nigeria. Because I know if they see the address Nigeria, they will give me something. I think like Chinese, right? I know what they think. So, see, per gram, per 50 gram is between 0.02 to $1.
Let us say $1.
And per hour is between 0.112 to 0.56. It doesn't make sense.
But how available?
Okay, let me correct this. Per hour actually is between $20 to, I think, $10 to $20 per 30 minutes.
Let's say 40
To, yeah, like $40. It depends also types of the filament, type of a complication, type of application. For someone you want to print this cover of the power bank, you want to charge him this much? Not worth it, right? But for somebody who creating the dentist, they take too much amount of money, right? I was telling my friend, I never go to the dentist, right? When I'm a child, I will remove it. He was scared. I said, I don't want to go to the dentist. Waste time? I don't have that time, right? Do you have? He said, yes, he has. He go there, he get injection, he got this, blah, blah. How much it took from him? So, different people, different, but it's good, right? It's good. And even people now are surprised that I never been to dentist, right? Yeah, he smiled and he had a good tip. So we reduce the waste. That's what I said initially. If you want to use a mold to create this as a mold and waxing with epoxy and all that, it will waste more material than just printing it with the 3D printer. How many times you have a bricklayer do some construction in your house and he leave the remaining bricks, right? The cement. You mix it, right? I didn't know that the bricklayer were doing bad to me until when the water come and wash out the sand. Then I see a big concrete laying like the whole street is my concrete. I say, hey, what this guy were doing? So they cover it with the sand after they do all these things. You know one thing I find? I find one bag of cement under. It's been crazy. Because Oga is not around, they do what they do, right? So we prevent the waste, actually. We reduce the waste. Just for prototyping. And we also, it is cost effective if you run it for small time and objects. But if you have to do some mega project, you need to think about the real thing, right? Create the model and then do the waxing and all that mold with the model you have. And but for running, in a small object, so it can be, it's limited actually. This is like telling you the advantage at the same time giving you the disadvantage, right? So if you have to go bigger, there will be a disadvantage because of time. There are challenges. We have the challenges and the limitation, material limitation. To have certain material is not easy. Titanium. I may order titanium from China, they will give me aluminium. Right? I may order stainless steel. I order stainless steel door when it comes with a special type of paint, right? This paint is expensive. But now, just the sun in my place make that paint to be cracking. Make sense? It's a special type of paint that anti-scratch and blah, 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 blah. But one rain, two rain, weather change, then I start to see it, the paint decay. I take the picture, I send to my supplier, hey, do you see a paint, Oh, you didn't tell me I was sending it to Nigeria. This is based on the weather in China. I told you I don't order directly, right? So based on their weather, that paint should last longer. But based on our weather, especially in the north, it's horrible, right? That paint cannot resist. So I agree, but I don't agree. Okay, so the material, there will be a challenge in terms of material availability and also the type of printer that can process that type of material. For example, if I want to use this 3D printer, can it use titanium and aluminum? No, I can't use that because it's not designed for that particular material. Printing speed sometimes is slow when you're considering a mass production. It can be fast for producing a prototype, yeah, you do it. But when you are doing something 3,000, 4,000.
But with regard to this mass production, can't we have a 3D that has multiple?
Yeah, you can have with the multiple head, right? Yeah. This is what we are trying to do here under reverse engineering to create our own 3D printer. So maybe we can have one 3D printer that we can send one instruction and the head will be printing maybe 10. It will be like longer. Yeah. It's a good idea. I buy your idea. Are you Chinese? I buy your idea. Yeah. I have seen somebody is writing this with a pen. He put 10 pens together. I don't know how he do it, and he's writing. These Arabic letters he's writing. And every time he writes, he has 10. He put in the ink and he writes. Every time he writes, he has 10. Good idea, right? Yeah. But if you have a problem, that's your disadvantage. Mass problem, right? Mass problem. So this is the thing. The size restriction. The 3D printer can print up to certain size, bigger or smaller. That's why I bring this. And I ask you that I will ask you some question. Did you see what inside?
Letter.
Okay. Did you see the size of the letter? How many sizes do you have? Small. How many sizes? How many sizes? You are not looking, right?
There are like 3 sizes, sir.
Are you sure? If you know, say it. If you don't know, say you don't know. Because you can't play that guesses with me. There are 2 sizes. Take a look, sir. I can print up to that size. I can print even lower than that size. But certain size, I will not be able to. You can share it with them. Let them take a look. Eh? Yeah, 2 sizes. This is small size. This is another side, right? I think none of you saw this size. You didn't see this. Because it's under. That's why I say take a look at it, because I'm going to ask you about it. It's too tiny. I can print lower than that, but certain, I cannot. And the same thing as you see here. So this is the first size. I can make this bigger, right? Then this is another size. Then I have another size, which is this. You need a glass to see, right? And I can still make a smaller size. But up to certain level, it cannot longer go. And I can make it bigger up to certain level. I cannot go. But I can divide this into 10 and attach it later. Let's say cut here, print here, cut here, print, separate and bigger object. So I can print a bigger A like this. But I have to attach the object. The size is restricted, right? I can make bigger, but smaller. I have some restriction up to certain level. Even though if you try some other printer, you cannot print up to that small size that you see. It's too small for some, even it's warning me. But I say, go ahead. I like trouble, right? Okay. Surface finishing. As you can see here, the surface finishing sometimes it matters, right? This is smooth, but this one is rough. Maybe the people online can see it. Okay, this part is a little bit rough, and this part is smooth. So sometimes it happens. And this is a basement. I still can remove this basement. Okay, I can remove it. Sometimes it's easy to remove. Sometimes I need sharp object to remove it. Okay, so I can remove it. Once I remove it, yeah, okay. This is a base actually to allow the object to be removed from the tray easily. Don't worry, we'll do this together so you can see how it is and how. After removing, you can see the side is becoming smoother in compared to this part. Okay, so there are many ways. Even how you make the base, you can make a declaration in your software how it's going to be. You have that compatibility or flexibility of deciding what to do with your printing. Clear? The cost is high for the 3D printer and the material. This material, we have to order it from somewhere else. This particular one comes from Turkey. Now we should think about all these polymers company, right, to start printing, making a filament for us, right, so that we can have indigenous plastic, ABS, whatever it is, right? So we need to have some partnership with some of the company so that we can have this filament in-house. So we don't need to order it from abroad or something like that. Okay, so this is one of the limitations. And the printer also is not that cheap, but I believe it's something we can do. Like the drones, all motors, right? 4 motors. This printer may have maybe, okay, the type of the printer that move the object have maybe just 3 to 4 motors. But this particular one have multiple motors. The one that take the tray up and down, the one that move it this way, move it the other way, move it here, move it here. All there are several motors. When we go, you can see it. Okay? And future of 3D printing. We're looking into the advancement in material. It can give more chance for printing more incredible items. Okay? And it can have You can have like fiber where the item will be stronger. As you can see, this is not that strong, right? I can still bring it, but because it is not, it's rough. It's like a shell, like a net. Okay, mesh. So that's why. But other than that, it's a good material. It can resist a lot of. You may have a hard time trying to break this, unlike plastic. Okay, so faster printing, improve the technology for quicker printing time. We have to think about the filament, the time that it said, and if we put item and before it dry, you put something on top, then it will linger on side, right? But we need to come up with some type of material that can set within the time and the cooling mechanism that will improve the speed of the printing. That will make it better. Then the large scale, some type of 3D printer printed like this size of the room. But there are 4 different type of application. But for this type of printer, we can make it a skeletal and increase the scale of that particular printer. What happened? We are almost done, and the computer is, I think, the network. Let me disconnect and then connect back. Sorry for the interruption. We have bioprint, which is hold on. What is time? Almost time, right? I got disconnected. Okay, because we have less time, let me try to finish this. I think we are almost okay. We are almost done. We can use a bioprint where we print a tissue, for example, or a human organ, bones, teeth, and so on. AI integration, designing optimized structure for parts. Imagine you want to send a spaceship to Mars, right? Or Jupiter or something like that. You need to organize it, right? You need to make sure you look at the weather, the environment, and how it reacts when it goes there. You want to make sure you clear the carbon footprint. Now the satellite you create and with the material that after maybe 4 years, because this is the duration for the cube satellite, most of them 4 years to 8 years, it will decay by itself. There will be a bacteria will be released from the somewhere inside the, and it will start eating it, and it will eat everything. But my point is, this bacteria is going well after it eat everything.
What happened to Nigeria and comes out?
No, that one is lost, and they say they trash it. They say they trash it. It is disconnected, and they trash it. I don't even believe it's trash. Maybe they are using it for their own use. No, it is our satellite, but we are not the people that control it. Now we shoot our own satellite, but they help us shoot it up. And you know what? The ground station, the main ground station is in China. Here we have a backup. Also, I went there. Last month I was there. I was a speaker there, on the space generation and all that. I was wondering. So, a lot of things. And I happened to see where our satellite was. It was at around 2 to 3. It was on top of Saudi Arabia. When it will come to Nigeria, it will be at night, and we don't have electricity. We will not have a good image. And they tell us something. When there was a tsunami in Indonesia, they captured that. So our satellite is working for Indonesia now. They tell Indonesia, they think they're Nigerian. They see that the sea, something happened in the sea, and they alert them, they ignore. And then there was a heavy impact. Next time they tell them, hey, they quickly evacuate the people. So what is our Nigerian satellite doing the day in Indonesia and doing at night in Nigeria? What is it for? We sponsor, we know everything, and it's not helping us.
So what action is government taking about that?
No, we are taking action here. We are using national European Union national satellite data to have the first data queue in Nigeria, here in the makerspace. And we want to use that to analyze. We use your weapon to fight you, yeah? So if we cannot use our own weapon to fight you, we will use your weapon to fight you. That's the only way. We have to be strategic. They let us pay for it, and they are using it. If you see the image from Dubai, from UAE, all at Abu Dhabi, Oman, and all that, you see nice images, Qatar, from our satellite. Because it is busy there watching these skyscrapers at the day. When you come to Nigeria, you see total darkness.
Because there's no lights.
We don't have lights.
They need to reprogram it.
That's what I told them. But they don't want to do that. Maybe they don't know how to do it. And I say, every cycle, we want this satellite because we have only one satellite. Every cycle, it needs to be either in our neighbor's country or our country. Go to our neighbor, because there is elapsing time, they call it. Go to our neighbor, like Chad, Cameroon, or go this way, Togo, Cotonou, Ghana, and either Nigeria, If not my neighbor, myself. Not a neighbor of neighbor of neighbor. I have to do with that. It goes within the line, right? It crosses that line. I want it to cross either my neighbor or Nigeria, and then go around again, come back. By that, it makes sense. But it will spend 7 days before it come back to Nigeria. And when it come to Nigeria, Wahala it's at night. And Ogasasa Aduhu already that is on duty. They will capture Nigeria like nothing. You will not see anything. They could use LiDAR to even penetrate and have this IR camera, to see at night. But I don't know. There's a problem here. We have a problem. So we can use this AI integration to, Yeah, but did you pay for it? See, this is the thing. Now we have to pay the tax, right? But all this mining activity and all that, they are not even paying the tax, right? Because they're illegal, and they keep talking about illegal. And nobody is talking about it because they are the one doing it. Right? And we that are trying to survive, eat, and we have to pay for building the country. While somebody will put in his pocket and put it somewhere. Why can't you take all this money from the mining? Ask them to pay the tax. It will cover us. Otherwise, I don't see what the government is doing for me. I go to hospital myself. I go to school myself. Everything myself. And I still pay for something that I eat.
Yes.
It's not making any sense. We don't have any leaders here, right? No, I can say it in front of them. I don't care. Yeah. So, in conclusion, we have this 3D technology help us to transform the way we do things, right? So we can do things faster in terms of prototype, in terms of doing something complicated and all that. And also, this technology continue to unlock the potential. We are always thinking of what can we do to take advantage of this 3D printing? We have the 3D printer, right? We are now trying to, we did some project in terms of energy sustainability under the makerspace. I'm heading that. And we are working on the patent now. The model we print to do all this research and all that using our 3D printer. Turbine and what, blah, blah. We use the 3D printer to print that, and we put the patent in process. Then we have the advancement, also continues with the 3D to become an integral part of the future design and manufacturing process. Most of the countries now, they look at the 3D printing as part of their manufacturing process because it helps them to resolve a lot of issues. They use the model to test. When it works, then they execute it into a manufacturing process. Okay, like China. You bring the item, they will first use the 3D printer, print one of it. How many you want? You see sometimes the price for 10 and 100 is almost the same, right? But if you are going 1,000, oh, you see the price is going down dramatically because they will have to get one model of it to prepare for the manufacturing. And once they have the manufacturing in the process, they have a very large scale, and systematic way of production that you cannot imagine. They are very good in that. Even your iPhone, you buy it assembled in California. No, forget it. It's assembled in China. It's all made in China. Nobody can afford, to do things in-house now. They outsource it. Okay. Any question? Is there any question? If there is no question, it's either you don't understand anything or you understand everything.
What kind of software do we use?
Yeah.
What kind of software do we use?
We'll show you. Don't worry. This guy is outside his shadow. He's living faster than his shadow. But don't worry, we will see. We use Lambda. Lambda is open source. There are many more. And our device comes with also slicing software. It has a special, customized, but it has a special type of type of model that it can use for slicing. Okay, what happened now? Yeah? Disadvantage? That's the limitation now. Challenges and the limitation. I'll give it to Abdullah.
Okay. So is it possible for a 3D printer to use different
Check if there is anybody commenting online. If there is any question online. No question? Yes, sir. What do you say?
Is it possible for a 3D printer, just like the one we have here now, that's using ABS? Is it possible for it to use another material to print also?
Yes, similar material. If for plastic type, it needs to be a plastic type. Even the plastic type, not all the type. Every printer has a specific type of filament that it can be used for printing. Our printer has about more than 20 different type of filament that can be used for printing.
Okay.
Yes, yes. Is that clear? Okay, what is the class code? Use the code that we used before for those who are online. I don't know. Do you have the code for the class? Okay, you don't tell me you think. You just give me the code. If you don't know, you don't know. So just post it to them, the code, so that they use it for the attendance. We cannot work on assumption. If you tell them, I think they put the wrong code, so they are not in the class, right? And not to posted the code? Okay then. Okay. If she posted, it's fine.
Is it possible for us to get the material?
Yes, I will put it not on the classroom. We have a new platform. They will enroll you, and you have the material, the slide, and the handouts. The handout will give you more detail, and I'll put some assessment some assignment. So I will disturb you with activity. I will ask you something that I don't even teach you.
We would love that.
Yes, now. Thank you.
You answer based on what we see.
No. I want you to go ahead. I want you to have open-minded and ready. Because imagine this class is just 3 months, and you have to cover 3D, you have to cover drone, you have to cover virtual reality, you have to cover computing cluster. If you don't put extra effort, you will not get anything. Yeah, so each one of them is a course by itself. See? So that's the thing. Okay? So I will give you something that you have to go and find it your own way, and then when you come, we'll discuss. You can do anything. You can use ChatGPT, and then at the end, let me see if ChatGPT will help you for defending it. Right? You know, I'm in academic for some time. I'm academia for some time. I know how to deal with my student. Right? I don't even bother myself with the plagiarism software. I don't care. Go and plagiarize. Copy from your friend. But you will meet me. Yeah? We'll meet each other. Yeah. A lot of my friend also, colleague, he give open book exam. And he said, you can discuss. You know how he said his question? You can use even computer. Doesn't care. But let's see if you can get it right. That means his question is application, not only application, maybe time series also. So
Okay, sir. You mean, I just remember something.
Yes.
When we were talking about jewelries,
yes,
painting of jewelries, and